In this next question, we have aspartame is an artificial sweetener. So draw a circle, they want a circle, nothing else, around each chiral center. So when you have a carbon double bond, it cannot be chiral. And we're looking at this being a chiral center. So there is one group, there is this group with the ester, there's this group with the amide, there's a hydrogen not shown because carbon form 4 bond, 1, 2, 3, there is one hydrogen there. This is the amide. This is not amide because this is not nitrogen. This is a carbon. It forms 4 bond, 1, 2, 3. There's a hydrogen there. This is a CH2. This is a CH2. The benzene ring has no chiral carbon. The CH2 has no chiral carbon. Doubly bonded carbon has no chiral carbon. The CH3 has no other chiral carbon. So there are 2 chiral carbons there altogether. In the next one, in the stomach, aspartame is hydrolyzed by acid. So this is hydrolysis of acid, and you get 3 organic products. We need to be very careful because we have an ester, we also have an amide. The thing with an amide is they are formed from amino acid. Hang on, no, I better correct myself. Amides are not formed from amino acid unless you have proteins. Okay, I better correct myself. You have amide, but it's gonna break down to something that has NH2, and NH2 is basic or alkaline. You are in acidic hydrolysis, so this thing will not survive as NH2. They will protonate and give you the salt with the acid. We don't know what acid is being used, but we know every single acid contains H+, so we don't know what is the counter anion, but we know it must protonate using the lone pair on the nitrogens and give you some sort of ammonium kind of ion where the nitrogen form 4 covalent bond, active covalent bond to this H+ there, and you will have a positive charge on the nitrogen. So if I have to break the ester bond, this is the ester bond that I'm breaking. So they say use arrow to indicate the 2 bonds. So they don't want dash. I have to follow the question. Use arrow to indicate the 2 bonds. They would be hydrolyzed. The first one is the ester bond. So here, this is the arrow. This is part 2. And then the other bond that I am hydrolyzing must be this one here. Not this one because this is carbon. This is not nitrogen. This is a CONH. So this is the amide bond. Whereas this is the ester bond. Okay, so there's amide there. And this is the ester bond that you're hydrolyzing. Draw the structures of the 3 products after complete acid hydrolysis. We're going to get the alcohol, which is CH3OH. So if I just show H3C and then OH, that is from there. I'm now going to complete this site with the skeletal formula. This is going to give me the carboxylic acid component. And then this bit here is just bonded to a carbon, which is that carbon. It has a CH2 benzene ring, so I will just draw CH2 and then benzene ring, just like the question. And then on the other side, I have an NH, but this is amide. The amide will get hydrolyzed as well. I should get NH2, but I'm under acid hydrolysis. The amines are basic. The basic will protonate. I will not survive with an NH2. Instead, what I will get is NH3 plus. I do not have the anion because we don't know what acid it is, but every single acid contains H+ in solution. The very last thing here, this thing will get broken hydrolyzed because your amide get hydrolyzed, and this thing will give you the carboxylic acid. This is the amine. The amine is not further hydrolyzed, but it will also protonate to give you the salt. And then this is carboxylic acid. It will remain as carboxylic acid. So looking at your structure there, I will get a carboxylic acid there, and then I will get the amine. So let me just complete the other side first. What am I doing? This is carboxylic acid. So I'm just going to show that the amine is going to protonate. So there's NH3 plus. So that thing is going to protonate as well. And that thing, when you form the amine, is going to protonate like that. So I'm just going to copy paste that onto the space given. And those 3 are the organic products that we will expect to get after complete acid hydrolysis. Of course, when you write equations, you might get water being formed somewhere to balance the equation, but they want the organic products. So these are the 3 products that you get after you chop off or fragment the molecule upon hydrolysis. That is the ester bond, that is the ester bond, and this is the amide bond that you have broken or hydrolyzed. This next question, by referring to the structure of aspartame, so you have to talk about the structure, explain why it is soluble in water. Solubility in water could be due to ion dipole bond. That is usually the origin of the solubility of ionic compound. But then what you have here is a molecule. So typically we could also be thinking about hydrogen bond. This is the main focus here, not the ion dipole bond, because aspartame are not these products here. Aspartame is this whole thing here. So what we can see is this is ester. Ester cannot form hydrogen bond because there is no hydrogen bonded to the oxygen there. This is amide. You have a dipole there, but that cannot form hydrogen bond because the hydrogen is not bonded to the oxygen. This can form hydrogen bond, so the NH can form hydrogen bond, the OH can form hydrogen bond. We are looking at OH and the NH that can form hydrogen bond. So aspartame molecule has OH and also NH. Both can form hydrogen bond with water because we are talking about dissolving in water, right? Can form hydrogen bond with water molecule. Typically speaking, when we draw hydrogen bond, we have to write in the dipole. So I'm purposely showing the dipole here so that you can see that these are very polar bonds as characterized by hydrogen bonded to the very electronegative atoms like fluorine, oxygen, and nitrogen. But of course, here's just oxygen and nitrogen there. So I identified the groups, and the groups can form hydrogen bond with water molecule. There's my second point. But which group can form the hydrogen bond? That is why it was 2 marks there. Okay. Now this next bit is actually on nanoparticles. Nanoparticle used to be part of the old syllabus as this option topic called nanotechnology. It has been taken out from the curriculum actually. So you don't really need to do it, and I don't really need to do it anymore as they are no longer relevant starting from the 2016 syllabus. And since we are in 2022, there's actually a new modification to that 2016 syllabus, and this is still not in the syllabus anymore. Okay, that's the end of that. I should say 8 marks question because I didn't answer these questions. And that's the end of this tutorial essentially. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. And do consider upgrading to the silver tier membership on my channel so that you can get access to all the yearly paper tutorials. And of course, the idea is to continue supporting the work that I'm doing on the channel that will help a lot more people like yourself. Thank you for watching.